So far we've talked about all of the sections of the MRAD report except for the visualizations. And spending time on visualization becomes increasingly important as we move from not just talking about papers, but talking about research posters, where someone makes a really big poster to present at a conference describing a research project, or when we talk about PowerPoint presentations, because there any data that is shown needs to be able to be quickly understood with a minimum of interference. Now, first of all, let me kind of preface this with some data. This is from an article I wrote that checks some things, checks some assumptions about communication in engineering. And so in this visualization, I looked at 10 industry or government papers and 10 academic papers. Now, the original story of the visualization that I focused on in my article was that pie graphs are very rarely used, and that was my main focus. But this data also, it's reflected in other studies that have done similar things more systematically. What we see are, are a lot of tables, line graphs, bar graphs, other type graphs, especially in academic writing. And line graphs are probably more represented in academic. Now, I'm skipping over illustrations. Illustrations are really common. So if somebody's talking about a bridge, they'll put a picture of a bridge. Or if there's a process, they might show a diagram of the process. Those are more idiosyncratic. I'm not talking about them. I'm just talking about data visualizations. And this is particularly when for instance, a lot of the problem solution papers we've been looking at, they have an experimental section where they evaluate something, and they have a method and results section. And so that's where we have a lot of data in here. So most data visualizations are of three types: tables, line, and bar graphs. And bar graph, bar chart, exact same thing, no difference. People go back and forth between them. There's a lot of other, but I'm just going to focus on these three main ones. So here are the main principles I'm going to talk about. Identifying the data story. And when we work with students on data visualization, we want to see what story do they want the reader to walk away with, and is the visualization designed to maximize that story, to really emphasize that story. I'll give you a brief overview on how to choose when we use different types of visualization, how to get rid of clutter, using sort, and using contrast to emphasize a story. So the first main point is really kind of focusing on the story something tells. So let me illustrate this by example. If we take a look at this graph here from a medical study, and it's a study on ulcers, and patients were given one of two different treatments. So go ahead and look at this, see if you can figure out the story. Most people will identify the story. This is a pretty simple graph, is something like triple therapy reduced ulcer recurrence, or there were fewer ulcer recurrences with triple therapy than ranitidine alone. Now, the story, and the graph is well designed to fit that story. Now, the story is not triple therapy versus ranitidine. That's not a story. That's just saying what it's about. And oftentimes, if you ask students what's the story here, they'll tell you what it's about. And that's often what gets foregrounded in reports or in PowerPoints or posters. Let's just look at a couple more examples. So this is essay ratings on students in an experimental section of a writing class and students in a control section. And the story, go ahead and pause if you haven't figured it out already, would be something like the experimental group outperformed the control group on 3 measures. The story would not be control versus experimental. Now, a graph of visualization can have multiple stories. This is from the dating website OkCupid, and I pull from this in a lot of my presentations and a lot of my work on data, because OkCupid, they ask their users all kinds of questions to match people up, but then they actually publish things on their blog based on what they found from the data. So this is length of relationship and age along the x-axis, and the blue line is people who use Twitter every day and everybody else. Now, there are actually two stories that this graph tells. And these stories, the main story is that Twitter users, daily Twitter users, have shorter relationships than everyone else. And then the other story is relationship length increases with age. So as you get older, people have longer relationships. Now, the reason I put that as a secondary story is that it's not very interesting. If I asked you who has longer relationships, old people or young people, I think we'd all get it right. Now, if I asked you who has shorter relationships, Twitter users versus, or daily Twitter users versus other people, we might have some disagreement. That's a more surprising story. Or maybe we wouldn't, depending on your position on Twitter. Again, the story is not relationship, A versus B. That's not a story. The story is the outcome, the conclusion, the moral of whatever the visualization is. And something that's useful, we use this newspaper analogy a lot. And of course, you guys saw this in Birkenkotter and Hucken. Think of it like a newspaper headline. And I ask students, I use this example all the time. Imagine a newspaper is reporting the results of a soccer match. You would never see a headline of Brazil versus Italy. You would see something like Brazil defeats Italy, or you might even have the score, so we have a sense of the magnitude. So really getting students to focus on the story. And the story becomes important in written research, especially if it's experimental. That story will appear in the abstract, but even if it's problem solution, often that evaluation component appears in the abstract. It definitely appears in the results section in a lot of detail. And in the discussion section, there is almost always a section that summarizes the main findings. So isolating that main story of a visualization, a particularly important one, really trickles down, permeates throughout an entire written report. In PowerPoints, this is very important. The story will often go in the headline, the sentence of a slide. And we'll be talking about PowerPoint design. And in posters, that story will often we want that story to be encapsulated in sort of the most visible parts of the poster. Now, of course, the more technical something is, the more important it becomes to foreground the story. So when I look at this is an excerpt from a research poster. I look at it and I'm like, these graphs look like two piles of colorful spaghetti. I'm not quite sure what I'm supposed to get from this. Take a minute and read this paragraph and see if you can figure out what the main story is here. Now, if I isolate the main story as unsupervised, this one is nearly as accurate as supervised Bayesian data integration, I'll see, oh, the point is that this pile of spaghetti is supposed to look like this pile of spaghetti. And they do. They do look pretty similar. So I can see that. And having this story isolated up here really helps me a lot figure out what I'm supposed to do with these very complicated graphs. It helps me figure out how to make sense of them. And it makes sense that, so something that's unsupervised, that would require less computational power, be something that would be easier. If it can do it nearly as well as supervised, that's a pretty interesting finding. That's pretty important in the field of computing. And lots of times you're going to see in some of these fields, the whole point of something is, especially when they're evaluating a problem solution, that A and B are pretty close, are pretty similar. We're within the ballpark, and we were able to do it using a cheaper method. Is almost as good or sometimes better than the status quo method that it's to replace. Now here's another less technical graph, but still fairly technical. And if you look at this for a little bit, I'm sure you could probably figure out what it is, but how much easier is it if I say, look, the point I want you to get is that project risk is higher just before injection stops. That really clarifies it. And again, the story is not something like conceptual model of risk over the lifetime of a project. So one question to always ask the students you're working with is figure out what the main story is and see where they want to place it, how visible. Sometimes in a paper that story might go in a caption. Again, this is a good thing to look at a model essay for where are they putting this story? How visible is it? And in general, if you don't have a model essay, then my default, what I would say would be best practice is to make that story as visible as possible. Try to get that in the topic sentence or the second sentence of something, or try to get it in the caption, or as in a PowerPoint, get it right here at the top in the complete sentence. And if there are multiple stories in a visualization, as there are in this table, then the writer needs to prioritize their primary and secondary story. So if we're looking at spam filters and comparing how they perform, we see that correct filter for most people is a more important criteria than the time, especially when the time is that close. So the primary story would be A is more accurate than B, but was somewhat slower. Here's one more one to look at to emphasize the importance of a story. And we're going to come back to this table a couple times. So take a look at this. This is some data about traffic on a road before and after they implemented a fog warning system. And I assume this traffic is under foggy conditions. Now, a lot of people will look at this and say, oh, speed didn't change. It even got higher after the system, which suggests that the system didn't work. But really, when we're talking about vehicle and vehicle safety and road conditions, what doesn't matter so much is the average speed of cars. It's the standard deviation. That's sort of the difference in speed. So that if you're going fast and you come up on someone slow, that's really a dangerous condition, much more dangerous than if you were both going fast. So reducing those deviations in vehicle speed really makes a big difference. Putting that sentence before the data to frame how people are interpreting the data will reduce the risk of someone misinterpreting it and say the system didn't work. And of course you can say the story different ways, so this makes it very clear. The system produced safer road conditions by reducing speed deviations. So isolating that story. One thing we sometimes say is don't ever leave the reader alone with your data because they might not draw the conclusion that you want them to draw from it. Now next, choose an appropriate visual representation. So focusing on our three main ones of tables, bar charts, and line graphs. We use tables most often when we have when you're reporting different types of values. So this is reporting percent and this is reporting time. Or if you're doing something that is milligrams and something else that's calories, you might do that in a table. You can't put both of those two different type units in a graph because then you're comparing very different things. Tables are also good when You have a lot of data that you're presenting. And if the story's not very interesting, tables are really concise. So a non-interesting story would be more likely to be in a table, whereas a figure, a graph, uh, sort of is a contract with the reader that this is worth paying attention to. So something like this, very appropriate representation for a graph because there's such a very clear story. And a line graph is appropriate because line graphs really show change over time. And there are exceptions. There are definitely exceptions to line graphs. But in general, if there is a line graph, people will first think that this is showing time because that association is so strong. Doesn't mean that if it's showing something else, it's necessarily wrong, but that's just part of the rhetorical situation. This is another one showing change over time. This is change in kilowatt hours for two different types of buildings. What bar graphs do well is they really help us show differences and similarities among groups, such as this one. Now, this also shows similarities and differences so that we can really quickly see and visualize that Turkey had much bigger change in life expectancy than the US, which is down at the bottom. Now, when bar graphs get too complicated, sometimes if we have too many bars, they just kind of go, So figuring out some other way to divide this up, maybe showing multiple bar graphs, one for 1990, one for 2012, or dividing these up in some other ways, which is a principle called small multiples, is possible. But another option can be a dot plot. And you will see this sometimes. These are becoming more popular. So this is just the same data as this, but instead of filling the whole bar in, we're just plotting the endpoints. And so this can be more useful for large quantities of data, particularly when they're showing a consistent story. 1990 is always lower than 2012. Dot plot becomes harder to interpret if the red and the blue were always switching places. One last type is a scatter plot, which is often used to show correlations. And you'll see some of that. So those were visual representations. Tables when your story's kind of boring, when you have lots of information, or when you have different units. Line graphs, especially when you want to show change over time. Bar graphs when you want to show differences among groups, and dot plots are a useful variation on a bar graph, a useful alternative to those. Now, next main point, get rid of clutter. This is something that we see all the time and becomes particularly important in situations that are very visual, such as PowerPoint or research posters. So here's this graph you've seen before of the two different ulcer treatments with lots of clutter. So let's slowly start taking the clutter off. And I'm going to start with the caption. Now, in a paper, there would always be a caption. In a PowerPoint presentation, it's not necessary because you aren't going to have more than one figure on a caption, or maybe you would have two, but they would be very closely related. So, and the speaker is there to talk people through. So, removing the caption. Next, let's get rid of all those data points. It's not really important. What's important, not these points, but the trends is what we want to see. We want to see that the lines are moving in completely different directions. Get rid of those grid lines. Get rid of the box around the legend there. And take a look how much cleaner the one on the right is than the one on the left. The head of design here at CMU says, like, engineers like to put everything in boxes. So a lot of times just removing the boxes and removing some of those grid lines makes it just a lot easier to see the data. And a key principle that we can say is remove non-data ink. So any ink, any type of lines, boxes, anything that is not actually reporting data is a candidate for removal to really help put the story into the foreground. So for instance, if we take a super ugly line graph like this, and what we really want to see is the trend, it's so much easier to see when we get rid of the background and get rid of the data points. And here I'm really focused on, wow, something weird happened in 1994. Whereas this, of course, you still get that story, but there's lots of things competing with that story. Whereas this, it really draws your attention to this dramatic drop right here. Same thing with tables. So we've seen this table before. With tables, the grid lines in here interfere with our ability to make comparisons across and down rows, across rows and down columns. If we get rid of the grid lines, and in this case I've moved miles per hour, which is reported 4 times, moved it over, much cleaner, much easier to see. See an even more dramatic difference. If we get rid of the grid lines, this is comparing how efficient some compression algorithms are to this. So much easier to see the numbers, to make comparisons. So original with very heavy grid lines, without the grid lines, much cleaner. Here's a bar graph with lots of non-data ink. Let's remove that. And that's much cleaner. So to go over what I removed, the gray background, the grid lines, the box around the legend. And I moved the legend up. Just a lot cleaner. There's less that interferes with the data. Here's a last example of a bar graph. This has a lot of boxes everywhere. If I just kind of remove those boxes and move things around a little bit, it's a lot cleaner. It makes it so that this feels to me kind of complicated, whereas this just aesthetically, kind of emotionally, feels a little bit cleaner. One last point when I'm talking about non-data ink, get rid of 3D. 3D is, unless that third dimension means something. If they're plotting that third dimension, if that third dimension actually represents data, then 3D can be useful, though it's challenging to interpret. But in this case, when 3D is just decoration, it interferes with our ability to comprehend. So if we look at 1989, is that data point, where is it? Is it at 100 million? Is it below 100 million? Or is it above 100 million? Do I look at this one in back, or do I look at this one in front? Whereas if I flatten it, just report it as 2D, and now I ask you, 1989, you see, oh, it seems to be kind of right at 100 million. There's no question. So when we have the two lines here, it makes it harder to see the data. So coaching students to get rid of any kind of 3D. Nobody's impressed with the ability to have that particular visual effect, or really most visual effects. All right, so we've talked about the importance of story, some different types of representations, getting rid of clutter. Now I'm going to talk to you about the sort. So often when we have students in the GCC, I ask them, why did you put the data in this order? And they're like, oh, that's just the order we entered it, or that's the order in Excel, or sometimes alphabetical order. So if we're looking at this chart here, which has, as you, I hope, recognize, a lot of clutter, a lot of non-data ink, if we sort it, and if the story we want people to see is which one has the lowest levelized cost and maybe which one has the highest, if we sort it, look how much easier it is to see the story. And we see, oh, geothermal, definitely the lowest. Whereas it's pretty hard to pick out in this one. So by cleaning it up, by sorting it, makes a big difference. Here's one that I use all the time. This is actual data from the 2008 Summer Olympics. So take a look at this and figure out the story it tells. And most people will say this shows that the US kind of won the Olympics, had the most medals. Here's the same data sorted differently. Now the story, the same table, the same data shows is that China had more gold than the US. And this was actually a big controversy during the 2008 Olympics. And you might not be surprised to learn that this is the version of the table that appeared in US newspapers and US media, and this is what appeared in the rest of the world. So how you sort a table really affects the story. What column the writer chooses to sort on really makes a big difference out in the reader's ability to interpret it, what they draw out from it as the main conclusion. So here we have a bunch of data on homicides in different states. And if I ask you what the story is, you can figure something out if you look at it for long enough. But if I sort it, so instead of sorting it alphabetically, I've sorted it from high to low, then you might say, oh, wow, Louisiana seems pretty dangerous and Maine seems very safe. Now we can also take that up a step and group it into particular areas. And now that I've grouped it, probably the story that jumps out is look at these southern states. Overall, they seem to be just a lot more dangerous, especially than the northern states, which are clearly a lot safer. So by grouping it and sorting it in particular ways, we can affect the story that it tells. With bar charts, we also can think, okay, what appears across this x-axis, which of these categories, and what appears in the legend? So if you look at this, this is the friction, the coefficient of friction, and more friction is good. They're talking about slipping on factory floors. So more friction is good. And this is the width of different shoe treads. Now what this data seems to tell, okay, here's my sentence headline in here, that large tread widths had higher friction, except for oily surface. But what I really get from when I look at this graph is that, wow, oil really has low coefficient of friction. And that's not a particularly interesting story because I didn't need a study to tell me that oil would be more slippery than water. So if I flip this around, and try not to get distracted by the different colors, but if I flip it around and move it so that shoe tread width is down here, and I've put water, detergent, and oil in the legend, now what my eye is really drawn towards is this big increase, and now I look and I'm like, okay, 1.2, that seems really good. And then as a secondary story, I'm kind of like, okay, doesn't make any difference on oil. All right, that's okay. Here's another example, a much simpler bar chart. This is comparing the emissions of two types of fuel. And if our story is that the Sago fuel, here in light gray, have fewer emissions than Yugo, this is, I mean, we get that story from here, but what I primarily get is like no catalyst has fewer emissions than catalyst. If I just flip it around and flip it like this, now I really see the difference between EUG and SEGO. And then I particularly see, wow, without a catalyst, SEGO is really good. Very few emissions. Compared to this, where that story, for me at least, is a little bit harder to isolate, whereas this really tells the story of the difference between the fuels. My last main point, and I have a couple smaller points, is to use contrast to emphasize the story. This is particularly useful when we have students working on PowerPoints or we have students working on research posters. So if we take this fog warning data, and again, I told you that standard deviation was important, so we could just put in red here, this lower standard deviation. And that tells us something that signals like, hey, I want my audience to look at that. So it adds additional emphasis to the story. Here's the homicide data. If I add some emphasis, put a box around this, your eye is immediately drawn to these 3 states at the bottom. A line graph, we have some non-data ink on here as well. These horizontal lines are competing with our ability to see these. But we can also, and this again is especially in presentations, if I want to really focus our attention on US men that are lagging, I could do something like this. Now that story, the low graduation rates of US men really jumps out at you. And I made up this data, so don't worry about it. So we have some choices about using contrast. And you'll also see, I'll come back to this point, that I moved all of the data labels up right next to the lines, whereas here it's in a legend. Most existing software does not make this easy to do. You have to do it kind of manually in PowerPoint or in some program. But if it's important, and if you're in a situation like PowerPoint where the visual presentation is important, this makes a big difference. We can also think about contrast with bar charts. This drives me crazy in Excel. Right now, the defaults in Excel and PowerPoint, if you create a chart, are to choose 2 colors that are in the same family. If you print this out in black and white, these are almost indistinguishable. It's really hard to see the difference. And so I like to recommend doing something. A good way to do it is to have a black bar, and then if you just have 2, I usually do the other one in light gray. If you have 3, then black, white, and maybe a medium gray for the next one. And then if you have 4 categories, maybe doing something with some kind of pattern. If you have more than 4 units in your legend, the writer should really think about some other way. That's starting to get too much, to get too overwhelming. All right, so here's our main point. Focus on the story, choose an appropriate representation, get rid of clutter, sort, and use contrast. Couple additional points. Use alignment. This is especially the case in tables. So if I were to ask you, pick out the 3 states that have the highest homicide rates. Go ahead and try and do that. Now if I line these up and I say, pick out the 3 states with the highest homicide rates, isn't it easier? You immediately see Alabama, Louisiana, and Mississippi they're an extra digit. It's very difficult. I bet most of you missed one on this. And when you have something like this, so first of all, one thing that I frequently work with students on is, do you need all those decimal places? Because that becomes overwhelming. And it also suggests, boy, you must have been really precise in your measurements. If someone is recording time and they go out to this many decimal places, I'm like, please tell me you didn't use a stopwatch and you're reporting it to that many decimal points. Is this really adding anything? So here's the same data. We just go out to one decimal place and we line it up so that we can easily see which ones go out to our single, the tens place, or the ones place, the tens place, the hundredths place, and so on. So let's focus on alignment with decimal places within tables, and this is something that just drives me crazy when people don't line them up or don't use a consistent number of digits. Now we can also talk about alignment on graphs. It can be easier. The closer the legend is to the data, the easier it is for someone to read it. And you can think about this in terms of how many eye movements, how far and how often does my eye have to move to make sense of this data. So if I just move the legend from the side, whoops, to right above, my eye has less to go, less distance to travel to make those comparisons. That's particularly the case if it's very boxy. If I move it up here, much easier to line things up. We already talked about this a little bit, and if I move it up, move the labels up right next to the line they represent, boy, it's a lot easier. This is pretty ugly graph here, but you can see on this one, I have to do a lot of work to reconcile, whereas if I put these right by the lines, so much easier. So lining things up can make a big difference in how much work the reader has to do to make sense of the data. And my last point is, and I've already alluded to this, one option is to use small multiples or break a complicated graph up into two graphs. So we might divide this line graph. This one's kind of a mess. The spaghetti graph into US and foreign markets. And it's a lot easier to make sense and pick out the data points. Here's another example. This is showing traditional and efficient classroom designs in 3 different locations in the country. One option is to break it up. Now, when I look at this, it becomes kind of overwhelming. I could move all these things over here, but because the points are so close to me, I mean, it still would just be kind of a mess. So if I break it up into different graphs, maybe one for each location, I'm noting that in Baltimore, there's a big difference. In Detroit, very big difference between traditional and efficient, but in Austin, not much difference. And of course, I can make total sense of this, why Austin would be different from Detroit and Baltimore in terms of energy efficient buildings. Whereas in this original one, pretty much the only story I get is that all of the lines go up in January, and all that's telling me is that across the board we use more energy in cold months. And I don't think I need a study to tell me that. Whereas this says, okay, they're kind of working better. All right, I'm going to make one last point. I know I kind of said I was wrapping up. I have one more point to make here, which is we also try to discourage students from using pie charts, especially when they're in more technical fields. If they're using it, I hate to say it, like in more of a business presentation, my apologies to people in Tepper. Now, that might be more appropriate, but if it's for a very technical audience, pie charts, they aren't very precise. They're not very useful, and they use a lot of ink to make a not very important useful point. So if we're looking at this, for example, how much bigger is company E and F? Which one actually is bigger? Now, if I put percentages around here, then we can tell what's bigger. Or I guess I was saying company A and E. That's kind of weird too. But now what I've done by putting these percentages on here is I've kind of created a table in circular format. That's even worse. So here I have to do, and this is also another disadvantage of pie charts. You have to do a lot of work sometimes to line things up. If I move all of this in here, this is I've just created a table basically, but in a circle. Here's the same data as an actual table, and it's much easier to comprehend. And then if we want to show comparisons across multiple pie charts, it becomes kind of difficult to comprehend. So if I want to see which branch grew the most between these two times, look at how often your eye has to move. And pie charts often, it's just not the best representation for the data. Here's the same data, and we see, wow, really big difference with Navy that was kind of obscured in the other representation. Big difference in Air Force that was obscured in the other representation. So our sort of party line about pie charts is that if it's for a technical setting, to really discourage students from using them. Pie charts they're imprecise, they're estimates, and if someone is in a technical field, precision is really important, so it really affects the ethos that they are projecting. So using something other than a pie chart makes more sense. And if you recall from the initial visualization I showed you guys, pie charts were, so out of the 20 reports and couple 600, 700 pages, I think there was one pie chart in the engineering reports that I examined, which gives you some sense of how commonly they're used. All right, so let me give you a couple of exercises. So this is a graph looking at coefficient of friction of two different types of pavement in wet and dry conditions. High coefficient of friction would be good because we don't want cars to slip and skid on pavement. So go ahead and pause and think about how you might redesign it. And here is one way that I redesigned it, including putting the sentence here. And this really tells the story that there's no difference when dry, but they are different when wet. This would probably be even better if I could move these up so they're right next to it. But if I did that, then I wouldn't be able to fit both of them on this PowerPoint slide without making the data really, really small. So, but I'm sure there's several things that you could do to show an improvement. Here's another one. Go ahead. This table is kind of a mess. See if you can figure out a few things that you might do to improve it. And here's what I did. So grouping them into different categories, using some contrast, so we can at least pick out a story in here and see which one is the best in each of these categories. Could be a way to do it. Another option, I collapsed some of these things, so I averaged the speeds and the memory usage, which maybe is or is not a good thing to do. One thing that is useful is it's easier to make comparisons if we're going down columns. Note how much easier that is than trying to do the same thing across rows. But it's not always possible if I'm going to have this much data. If I tried to flip it, this would just take off. This would go off my screen. I wouldn't have enough room. But it is easier to make comparisons this way. Now, okay, wait, I have one more for you to look at. This is from the Body in the Loop paper, the robotics paper that we looked at a few weeks ago. Now, this is telling two stories, and again, having a story up here would make a big difference. So one story is that the simulations, which are these stars, are almost as accurate as the actual data. I'm sorry, I got that confused. The experimental data, the actual data, are the stars. The simulations are the more symmetrical curved lines here. And so one thing is that overall they're not too far off. A second point that they're making, and I know this from reading the article, is that the pressure. So these are the different types of pressure. So with a low pressure bar, there's more angular deflection than with the high pressure bar. This would definitely be easier to see if we had the legend up here matched up to the actual data points. And if we got rid of these grid lines, which are definitely not doing anything for the writer, and we could even get rid of some of the bars and put these in color code. Overall, I think this is reasonably telling the stories the writer wants to tell, but there's a lot of stuff that is kind of interfering and could help us grasp that story more easily. Now, so this is one of the articles we've already read. I want to bring your attention to a really good model. This is from the password guessability study that you looked at for the literature review, and some of you looked at earlier in the semester. And one thing that's nice is just how well they label things and how much they describe in the caption. So they're looking at what makes for safer passwords. This is the one where they got all the CMU passwords. And so this also amuses me that if the user was annoyed when they were creating their password is more likely to be guessed than if they were not annoyed when they were creating their password. And so this just lends to my general theory that the world is a better place when I am not annoyed. This one here, if we look at figure 5 here, just look how easy it is to get the story just from looking at the figure without even going to the text. Everything we need is right here. It's really easy to see the differences. Yes, I would probably take out these grid lines, and that would be even easier, but at least they're light, so that they don't interfere that much. So that it's really easy to see that if they substituted numbers. So if I was doing wolf and I did W0 LFE, that's not half as clever as I think it is. Whereas if I include numbers and I do wolf 23, that would be less guessable. So throughout, if you want a good model, I think this results section is very well written, and it's really easy to get main points from the graphs in here. What I would like you guys to do is to return to some of the articles that you read. Here, I'm going to go ahead and look at one more that you guys read. So this is from the article that the Information Systems group read. I'm just referring to this quick table right here. So I looked at the text, and the story of this table, the story they end up telling, is that JAS consistently falls between these two, between I forget. It has something to do with the order of these, but they aren't in any particular order. Okay, it's supposed to be that JAS is better than ROC, which is better than PAS. Now, also, if these are fractions, why display them as fractions? Why not put 0.5, 1, 0.66. That would just be easier. I wouldn't have to do any math. Is there some reason to display it this way? I mean, then why is this one not displayed the same way? So this it's a super simple story that seems to be made much more complicated by some of the decisions the authors have made. So what I'd like you guys to do is to return to the articles, and this will be the last time, I promise, and you can then give them up and look at the data visualizations. Pick 3 of them, see if you can find the main story, and see if you can think of ways that these could be improved. So just pick 3 random ones, or 3 ones that you feel like that you understand and can kind of figure out. And we'll share these in class and maybe put them up on the document cam. One thing that I want to make sure that we clarify is, so when I'm talking about data visualizations, I don't mean diagrams like this one right here. This is a diagram. It's sort of showing me how their network works or what they did. So something that's a diagram or illustration is not a data visualization. I'm looking for something where they actually collected data and are reporting that out. So go ahead and find 3 visualizations, share them, make sure that you understand the story, and talk about ways that that story could be even further emphasized.